Hello friends, in this video we are going to learn about AWS messaging and queuing services, Amazon Simple Queue Service or Amazon SQS, and Amazon Simple Notification Service or Amazon SNS. This is the agenda for this video. First, we will see why messaging and queuing is important or why it is needed in your business. Then, we will talk about tightly coupled and loosely coupled architecture. Then we will see AWS messaging and queuing services, Amazon Simple Queue Service or Amazon SQS, and Amazon Simple Notification Service or Amazon SNS. At last, we will have a quiz and also we will see answers to the previous quiz. If you have not watched the previous video, you can watch it by clicking the I button above. So, let's start. First, let us understand why your business needs messaging and queuing services by a simple example. Suppose you are owner of a shop which sells some products. Now, in your shop, there are cashiers who are taking orders from the customers, and there is also a team who is delivering those products to the customers. Currently, the cashier takes the order and writes it down on a piece of paper and then gives it to the delivery team. Then the delivery team delivers the item to the customer and completes the order. The same process repeats again and again. But wait, this process only works smoothly as long as both the cashier and delivery team are in sync. What if the cashier took the order and turned to give it to the delivery team and there was no one available in the delivery team because all were busy completing the previous orders? Well, now there is a chance that cashier might keep the piece of paper on which order is written at some place from where anyone from the delivery team can pick it up and complete the order. But what if that piece of paper got lost or something else happened? Now, due to all this, this order will get dropped probably. You can clearly see how this process will fail, which will cause failures to complete orders at all. A much better process would be to make a system and introduce some sort of queue in it. By doing this, the cashier will post the order directly in the system instead of giving that piece of paper to the delivery team. This idea of placing orders into a system queue is called messaging and queuing. Now, let's talk about tightly coupled architecture and loosely coupled architecture. The applications also send messages to each other in the similar way as the cashier sent orders to the delivery team that we have seen in our previous example. If applications communicate directly like the cashier and delivery team, it is called tightly coupled architecture. Applications are made of multiple components that communicate with each other to transmit data, fulfill requests, and keep the application running. Suppose that you have an application with tightly coupled components. This type of architecture makes a monolithic application. In a monolithic application, if a single component fails, other components also fail and the entire application fails. A more reliable architecture is loosely coupled. This type of architecture is called a microservices approach, which helps to maintain the application availability when a single component fails. If a single component fails, the other components continue to work because they are communicating with each other. The loose coupling of components prevents the entire application from failing. When designing applications on AWS, you should take a microservices approach, with services and components that fulfill different functions. The two services that facilitates microservice approach are Amazon Simple Queue Service or Amazon SQS and Amazon Simple Notification Service or Amazon SNS. Let's look at both of them one by one. First, let's see what is Amazon Simple Queue Service or Amazon SQS. Amazon Simple Queue Service or Amazon SQS is a message queuing service through which you can send, store, and receive messages between software components without losing messages or requiring other services to be available. In Amazon SQS, an application sends messages into a queue. A user or a service retrieves a message from that queue, processes it, and then deletes it from the queue. Now, let's understand how Amazon Simple Queue Service or Amazon SQS works by a simple example. We have already discussed the example in which cashier and the delivery team are two separate components of an application. A message queuing service such as Amazon Simple Queue Service or SQS enables messages between decoupled application and components. In this example, the first step in the process remains the same as in the previous example. A customer places an order with the cashier. Then, the cashier puts the order into a queue. You can think of this as a system that serves as a link between the cashier and the delivery team. Now, even if all the persons in the delivery team are busy with another order, the cashier can continue placing new orders into the queue. Next, the delivery team checks the queue and retrieves the order. Then, the delivery team prepares the order and gives it to the customer. The delivery team then removes the completed order from the queue. When the delivery team is completing the order, the cashier can still continue to take new orders and add them to the queue. For decoupled applications and microservices, Amazon Simple Queue Service or Amazon SQS enables you to send, store, and retrieve messages between components. This decoupled approach enables the separate components to work more efficiently and independently. Now, let's see what is Amazon Simple Notification Service or Amazon SNS. Amazon Simple Notification Service or Amazon SNS is a publish, subscribe or pub/sub service. Using Amazon Simple Notification Service or SNS topics, a publisher publishes messages to the customers or subscribers. In Amazon SNS, subscribers can be web servers, email addresses, AWS Lambda functions, or other options. Now, let's understand how Amazon Simple Notification Service or Amazon SNS works with the help of a simple example. Suppose that a shop has a single newsletter that includes updates from all the areas of its business. It includes topics such as coupons, new products, and blogs. All of these topics are grouped because this is a single newsletter. All customers who subscribe to the newsletter receive updates about coupons, new products, and blogs. After some time, some customers expressed that they would prefer to receive separate newsletters for only the topics that interest them. The shop owner then decided to try a new approach. Now, instead of having a single newsletter for all topics, the shop owner has broken it up into 3 separate newsletters. Each newsletter is devoted to a specific topic: coupons, new products, and blogs. Subscribers will now receive updates immediately for only the specific topics to which they have subscribed. Now, it is possible for subscribers to subscribe to a single topic or to multiple topics. For example, the first customer subscribes to only the coupons topics, second customer subscribes to only the blogs topic, and third customer subscribes to both the blogs and new product topics. Now, it's time for a quiz. Let's look at the questions. The first question is, which AWS service is best choice for publishing messages to subscribers? The options are Amazon SQS, Amazon EC2 Autoscaling, Amazon SNS, or Elastic Load Balancing. The second question is, which AWS service enables you to send, store, and retrieve messages between software components? The options are Amazon SQS, Amazon SNS, AWS Lambda, or none of the above? Make sure to answer both the questions in the comment section below. Now, let's look at the answers for the quiz we had in previous video. If you have not watched the previous video, you can watch it by clicking the I button above. The first question was, your company wants to run an application without provisioning or managing the servers. Which AWS service will you use? The first option was Amazon ECS. This is not the correct option, as Amazon Elastic Container Service or Amazon ECS is a container management system that enables you to run and scale containerized applications on AWS. The second option was AWS Lambda. This is the correct option, as AWS Lambda is a service that lets you run code without needing to provision or manage servers. AWS Lambda is an AWS service for serverless computing. The third option was EC2 instance. This is not the correct option, as while using the EC2 instances, we are responsible for provisioning the instances, patching the instances, and maintaining the instances. So, the right option is option B. Second question was, you want to deploy and manage containerized applications. Which AWS service should you use? The first option was AWS Fargate. This is not the correct option, as AWS Fargate is a serverless compute engine for containers. When using AWS Fargate, you do not need to provision or manage servers. Second option was AWS Lambda. This is also not the correct option, as AWS Lambda is not a container service. Third option was Amazon EKS. This is the correct option, as Amazon EKS is a container service that you can use to run Kubernetes on AWS. So the correct option is option C. We will learn more about cloud computing in upcoming videos. Please subscribe the channel for more such videos. Thank you.